Hi, myself Naveen Kuma in the course Wireless and Mobile Communication System. Today we are going to discuss the topic that is multiplexing and the multiple access. So first of all, we must know what is the meaning of multiplexing and then the multiple access, and what is the difference between these in the wireless communication systems. So when this is a very simple term, that is multiplexing. In multiplexing, what we do, we have the multiple data streams and we combine them. So in this technique, one channel is used for transmission of the signals, because we have the multiple streams which we are going to combine and we transmit through the transmitter to receiver. So in this, some of the examples in multiplexing is the TDM, time division multiplexing, frequency division multiplexing, code division, and the space division multiplexing techniques. So there are the many more multiplexing techniques are there. And second is the multiple access. So in that multiple access technique, the multiple access techniques are channel access methods. It means how the different users can access the channels. That is called the multiple access techniques. And these are based on the these principles are basically includes the multiplexing also, and in that it allocates the channels to the different users and also handles the situation when there are more message sources than the available channels. It works on the data link layer, that is L2 of the OSI model. So in that in these multiple access techniques, when we have the one channel or the one band of the frequencies, so how the different users can accommodate or use those particular band of frequency in which method. So that method is called the multiple access, means accessing the given bandwidth by the different users. So in that some of the examples are, that is TDMA, time division multiple access, FDMA, frequency division multiple access, code division multiple access, OFDMA, orthogonal frequency division multiple access. Then we have the SC OFDMA, that is single carrier OFDM, orthogonal frequency division multiple access, and then the SDMA, space division multiple access. So these are different methods how we access the channel, and this access of channel by the different users, that is the multiple access. So in that multiplexing and the multiple access, it depends on the available bandwidth, right? So as we said, in the multiple access, what we do, we simply access the given bandwidth. So how these bandwidths are defined by the different channels. So in that that is depends, this available bandwidth is allocated to the users, and these techniques can be classified in the two ways. First one is the narrowband system, second one is the wideband system. So these are two ways through which the given bandwidth can be accessed by the different users. So in that narrowband system, so these systems operate with the channels that is substantially narrower than the coherence bandwidth. So this is a definition of the narrowband system, in which the channel bandwidth, that is BC, that must be lesser than the B coherent. This is the coherent, right? So you can say this is the BS, that is less than the BCO coherent bandwidth. So that bandwidth, that system is called the narrowband system. Next is the wideband system, in which the transmission bandwidth, that is BS, that must be, if it is the greater than the coherence bandwidth, that is the BCO, right? If this is the case, then in that case we call it as the wideband systems. Okay. So there are some disadvantages and advantages of the narrowband system and the wideband systems. So wideband systems suffer the ISI, which very drastically influence the transmission of the signal, but the narrowband system can be managed easily, but it's severe with the very less ISI. Right. So that is why the narrowband system, which is of very you can say this data rate is low in this case, but the ISI will be very less. So when we talk about the frequency division multiple access technique, in that case there are the different users which we have, that is the user 1, that is user 2, that is the user 3 and the user 4, and we have the one common channel through which we can transmit the data. So it means how these different users can access this channel. So it depends on the different multiple access techniques. So out of them we have the first one, that is the frequency division multiple access. In that user 1 can transmit. Okay, so if what we do, we divide this frequency into the different subcarriers like f1, f2 and so on, right? Similar to that, all the users have a different band of frequencies, just like the f1 and then f2 and f3 and so on. Similar to that, f3, this one is the f1, f2, f3 and so on, right? Similar to that, then we have the user 4 have the different data on the different channel, that is the f1 on this, you can say, right, f2 and so on. So if we see by using the common channel, so in this case you can see that in this channel the frequency f1 is given by the f4, and then frequency f2 is given by the f3 user, and then this one, that is the user 2 can transmit the data, that is through the this is frequency 2, right? And then first one is the this one from the user 1. So different, all the 4 users can access the channel by transmitting the data different subcarriers, right? So this is subcarrier number 1, subcarrier number 2, 3 and 4. So in this way these 4 data can be transmitted through the channel in a given time slot, right? If this one is the data in this way, this bulk of the burst of data can be transmitted through the given through a given channel. So this is the frequency division multiple access. So in this way this data can be accessed by the users. So it reduces the bit rate information and uses the efficient numerical codes, increases the capacity. So this is one of the very major advantage of the FDMA, in which the capacity can be improved because different subcarriers can have the different data streams, and it can be transmitted through the given common channel by using the multiplexing technique. Second, it reduces the cost and lowers the ISI, that is inter-symbol interference. So in this case equalization is not necessarily required, as we are aware that equalization is required to mitigate the ISI, right? So this this is used to mitigate ISI, right? So but there is no external extra circuitry is required in the case of the FDMA to mitigate the ISI. So when we convert the wideband to the narrowband system, so in this case the ISI can be removed or the mitigate or the reduce. Then FDMA system can be easily implemented. A system can be configured so that the improvement in terms of the speech coder or the encoder and the bit rate reduction may be easily incorporated, right? Because when we convert the wideband to the narrowband, in that case the bit stream data rate will be lesser as compared to wideband. So we divide the very high speed data rate into the lower speed data rates into the narrowband systems. So here that the transmission is continuous, less number of bits are required for synchronization and the framing. So these all are the advantages of the FDMA system. If we talk about the disadvantage of FDMA system, so in that it does not differ significantly from the analog systems, right? So in improving the capacity depends on the signals to interference reduction or a signal to noise ratio. Then maximum flow rate per channel is fixed and very small. Guard bands leads to a waste of capacity, and hardware implies a narrower filters which cannot be realized in the VLSI and therefore increases the cost. So there are some of the disadvantages of this system, in which when we have the wideband system, in this case the signal to noise ratio will be very less and the interference is very high. Second point is if we use the guard bands in the FDMA system, because we have to remove the overlapping between the signals. So in that case the waste of capacity is there, because the guard band also nothing but the band of frequency. And then hardware implies narrowband filters, because when we convert the wideband to narrowband system, so narrowband filters are required, that is the hardware, and which is very costly in nature. So we always try to remove this kind of filters or this kind of hardware, so that we can reduce the complexity of the system. Second one is the time division multiple access in TDMA. So in that, it uses the entire bandwidth of the communication medium and establishes a time frame. So in that, what we do, in place of the frequency, we use the we take the time frames, right? So this time frame is divided into the subframes. So like that, just like the user 1, right? In the user 1, we can transmit the data by user 1 at the one time slot. So this one is a T1, we can say. Similar to that, user 2 can transmit the data in the T2 time slot. User 3 can transmit the data at the T3 time slot, and in the by the user 4 can transmit the data at the time slot T4. So this channel, this is the one common channel which can be accessed by this different users. So that is a multiplex, that is the multiple access. How this common channel can be accessed by the different these four multiple access techniques. So when we combine the data from all the users from user 1, 2, 3 and 4, so this technique is the multiplexing, right? So this is the way how multiplexing and the multiple access can be used for transmitting the data. So there are some of the advantages of the TDMA system in which the data can be transferred through the different time slots, right? So I hope you understood the difference between the FDMA and TDMA. In FDMA, we use the subcarriers for the different data transmission, and in the TDMA system, we use the different time slots for transmitting the data. So the advantages of the TDMA system is that permits the flexible rates. So in that, the several slots can be assigned to a user, right? And this assignment, these are different strategies for assignment of the slots to the user. So in that, first in this, the one time interval which translates the 32 kbps, a user assigned 2 kbps slot per frame. So as I said, the different frames can be divided into the subframes, right? And these subframes are divided into the different time slots. So this is an example in which it is mentioning that in each time slot, the one data can be transmitted through the 32 kbps. So if we require 2 time slots, so in that case, that 32 into 2 means 64 kbps data can be transmitted through the 2 time slots at a time. Okay. Second, it can withstand gusty or a variable bitrate traffic. So it can be changed as per the requirement. Data traffic can be changed. So number of slotted allocated to the user, and it can be changed frame by frame. For example, 2 slots in the frame, right? So 2 slots in the frame 1 and 3 slots in the frame 2 and 1 slot in frame 3, frame 0 of the notches 4. Means the different frames can be divided into the subframes, and those subframes are divided into the time slots, and these time slots can be accessed by the different users, right? So when we access that different time slots, so depends on the user data, these time slots can be used to transmit the different bit stream data rates, right? So these are the representation, how this is example how we access the subframes so that we can transmit the data. So next advantage is the no guard band is required for the wideband system. See, in the FDMA system, we know that the wideband one guard band is required in the case of FDMA system, which was the disadvantage. Why? Because it was taking the some part of the frequency band. See, we have very limited frequency band, so that we have to utilize it very efficiently. But in the FDMA system, when we impose some guard bands into the FDMA, in that case there is a wastage of the capacity. But the benefit in the TDMA system is there is no guard band is required. Okay, so no narrowband filters are required for the wideband system, right? So in the TDMA system, no narrowband filters are required, but in the FDMA system, we require the narrowband filters because we have to convert the wideband system into the narrowband system in the FDMA system. So what happened, the wideband frequency can be have to be converted into the different subcarriers, and these subcarriers are spaced by the different guard bands, right? But these all things are not there in the TDMA system, so it is very beneficial in that case. So there are some of the disadvantage also in the case of the TDMA system. So in that the high data rates of the broadband systems require the complex equalization. So this is the one of the very efficient way to reduce the ISI, but it requires a very heavy or complex circuitry of the equalizers, right? So we have the different equalizers, just like the adaptive equalizer, okay, and decision feedback equalizers. So we have various equalizers techniques to mitigate the ISI, but in that case the equalization requires the more complex circuitry. So these are one of the disadvantage. So due to the burst mode, a large number of additional bits are required for synchronization and the supervision. So for the synchronization purposes, the extra bits are required for the synchronization purposes. But in the case when we talk about the FDMA system, so in that case we require the one clock for the transmitter and for the receiver, but it doesn't happen in the case of the TDMA system. Okay, so next is the call time is needed in each slot to accommodate time to inaccuracy due to the clock instability, right? So as I just mentioned about the clock instability system in the TDMA system. So electronics operating at high bit rates increases the energy consumption. So when we impose the high data rate in the TDMA system, so when we transmit the data with very high data rate, so in that case what happen, more power is required to transmit the more bits. Just like if we have a QPSK system or we have a 16 QM, so it means we require 2 times more bits at a time in the QM system. So what happened? So more power supply is required for the transmission of a signal. So complex signal processing is required to synchronize within the time slots, as this is the same as we have just discussed about the synchronization part. So synchronization is the very important part in the TDMA system, which is required to be maintained stable between the transmitter and the receiver. If there is a lack of synchronization, in that case the receiver will not receive the dedicated data streams. Okay, so next is the code division multiple access technique. In that case what we do, again we have the 4 users, that is the user 1, user 2, user 3 and the user 4. So what we do in the case of CDMA system, we modulate the signal by the different users by using the different codes. Just like the PN sequence or the PN codes, we are very much aware about the spread spectrum modulation technique, which was in the last lecture which we have given already. In that case what we do, that the data stream by the user 1 will be multiplied with the code, means we are modulating the D1 or the data with the code 1. So in the same way, user 2 will have the code 2, user 3 have the code 3, user 4 have the code 4. Means all the different users have the different PN codes. So data can be multiplied or can be modulated by the different codes in the code division multiple access technique, right? So these are different from the FDM and TDM. In FDMA what we have done, by using the different subcarriers. In the TDMA we are using the different time slots. In the case of CDMA we have the different multiple codes, which we have different codes must be there. There are some of the properties of the PN codes which we have already discussed about the balance property, run length property, autocorrelation property. So these codes have to be maintained, all these properties, right? So okay, so this data will be transmitted by the user 1, and this is the, we are using the same common channel. So this is the definition of the multiple access, that the common channel can be accessed by the different users. So this is a multiple access. So this D2 C2 is coming from the user 2, and D3 C3 is coming from the user 3, and D4 C4 is coming from the user 4. So in that way, that this is the multiplexing is applying here by combining all the data in the one common channel, and transmit from the transmitter into the channel. So this is nothing but this is the medium. This is the medium in which we are transmitting data from the different transmitters or the users. So in one frame we can see how we have represented the FDMA system, in which the system bandwidth is divided by the different subcarriers. So this one is a subcarrier number 1, subcarrier 2, 3, 4 and so on, right? In the case of the TDMA system, we use the TDMA frame, and these frames are divided between the different sub slots or the subframes. Just like this is the one frame. So in this one frame, this one, right? This one is the number subframe. So this is the one subframe, and all the subframes comprises the 1, 2, 3, 4, 5, 6, 7, 8. So 8 slots are there in a one subframe. Similar to that, we have the multiple subframes, and combining all the subframes are called the one frame, right? So in TDMA system, we transmit the data through the by using the different time slots, right? So time slot 1, time slot 2, time slot 3 and so on, right? So then we have the TDMA system. In that case, what we do, we simply multiply the data rate by the different codes, right? Just like the code 1, code 2, code 3 and so on. So this is representing into the time and the frequency plane, in which you can see in that way, if this is the time frame and this one is the frequency plane, so in that case we see this is the CDMA frame, right? Time, frequency and the, you can say okay, I will write it, time, this is the frequency and this one is the code, right? So all these three must be orthogonal to each other, right? So that we can transmit the data in that way, that if we are taking the time in this way, then the system will be TDMA, in the above it will be FDMA, and below it will be the CDMA. Okay, so in this way we transmit, we access the common channel, and by after accessing the channel, we combine all the data by using the multiplexing techniques. So there are some of the advantages also in the CDMA system. What is that? Let's go one by one. CDMA has a soft capacity, and the greater the number of codes, the more the number of users. It has the following advantages also, as we have just mentioned about the number of codes representing the number of users. So the CDMA system requires tight power control system. So this is a very major concern in the CDMA system, where we have the near field or the far field. So in that case, the tight power control system is required. So this is the one of the, also you can see the disadvantage also in the case of the CDMA system. So we require the optimum power control mechanism in the CDMA system. It suffers from the near far effect, as I said. In other words, a user near the base station transmitting with the same power will drown the signal later, and all signal must have the more or less equal power at the receiver. So what is our main concern? If we have any of the base station, or we have the user, suppose one user is lying here and second user is very far, right? So our main target is what? That the user 1, suppose this is user 1 and the user 2. So if user 1 transmit the data at the base station, and also the user 2 is transmitting the data at the same base station, so in that case the SNR value at the base station must be same, right? This must be, you can say, if this one is SNR 1, then must be equal to the SNR 2. So SNR 1 from the user 1 and SNR 2 from the user 2. So it means if this base station is transmitting the same power, and this user is transmitting by the base same power, and this user is also transmitting same power. So in that case, what will happen? The user which is near to the base station, signal to power ratio will be high as compared to the user which is very far away from the base station. So in that case, the SNR 1 will be greater than the SNR 2. So this effect have to be maintained by the CDMA system. Next is the rack receivers. So these rack receivers can be used to improving the signal reception. Then signal reception and delayed versions of the time. So that delayed version of time, that is the one slot, is called the one chip of the signal, and it can be collected and used to make the decisions at the bit level. So the solution for this CDMA system is the rack receiver. So in the rack receiver, what we do, we use the different correlators. We use the different correlators. So these correlators are nothing but, these are the matched filters, right? So these are the matched filters. These are the matched filters, right? So after that, these, okay, so this is nothing, this is like this, and this one like this. So at the end, we combine all these signals, right? This is the output. So in the rack receiver, what we say, we use a different correlators. A different correlator, if we have n number of correlators, it means we have n number of branches. M number of branches means n multipath, right? If we have the n number of correlators, it means n number of multipath, n number of multipath, right? So that is also equivalent to the branches. This is also equal to the branches, or we call it as the fingers, right? We also call the different fingers. So this is the concept behind the rack receiver, which we will cover in the next upcoming lectures. What is the rack receiver and what is the benefit of this, and how we combine the signals at the receiver side, right? So we call it as the rack receiver in the CDMA system. Okay, next is the disadvantage of CDMA. So again, the time synchronization, which is very severe effect of noise and the ISI in the case of any of the technology. Okay. Second is as the sum of the power received and transmitted from the base station needs constant tight power control. So this result in the several handovers, right? So as I have just mentioned the previous slide, when we have the user is coming, see in the previous case we can see, just as I mentioned, if this one, suppose this user 1 is connected with this base station 1, just for example, so this will be into the one cell. Now if user 2 is not in the one cell and this is in the second cell, which was connected previously from the second base station, right? So in this case, what happened? So when it is moving from from the cell 2 to cell 1, so you can see this is nothing but this is the overlapping, right? So it means when it is moving from this point to this point, so this one is nothing but when the user 2 is in this region, so what will happen? So this signal, this user will connect at the same time will connect from the base station 2 and the base station 1. So in that case, there is an interference into that, but they are transmitting with the same power. So in this way, this overlapping creates the ISI between the cell 2 to cell 1. So in this case, the power control can be managed in that way that the base station 2 and the base station 1 must be coordinated very efficiently, right? Then this CDMA work very properly. Otherwise, if there is no power control circuitry is there or optimum way, then there is a very issue in the CDMA system. Okay, so that is why the handover will occur, right? So handovers we have already discussed that what is a handover between the user 1 to user 2, right? When it is overlapping between the cell 2 to cell 1. Okay, so multi-carrier modulation techniques that was used in the from the CDMA TDMA system into the multi-carrier. So in the multi-carrier, we just will give the brief of that one. In the multi-carriers are similar to the FDMA system, in which we use the OFDMA to minimize the ISI. So in that multi-carrier system is the example for this one is the OFDMA, right? And what the purpose of this OFDMA? This is to convert wideband to narrow band system. Is it okay? So it means OFDM system is to convert the wideband to narrowband system, in which because of this you can say the high data rate to low data rate. So what is the effect of this one? The effect is very low ISI. So this is the benefit of using the multi-carrier system into the wireless communication system. So all the techniques generation 3G and 4G, they use the multi-carrier modulation techniques, in which the OFDM system was used for the uplink or the downlink. So for the downlink we have the OFDM system, and for the uplink we have the SC FDMA system. So the reason is for the power control in the case of OFDMA system, which suffer from the PAPR, right? Peak to average power ratio. So to minimize all these things, we have to take care about the SC FDMA or OFDMA system. Okay, thank you very much.